of O-level chemistry MCQ paper, and we're going to be doing today May-June 2020. I was going to be doing winter 2020, but then I found these questions to be even harder, and the grade thresholds for this particular examination weren't available. I'm assuming this is harder than May-June's. First question is easier. It says the diagram shows four pieces of apparatus that are used to measure the volume of a gas or liquid. Which piece of apparatus should always be filled to the same level? So we are just concerned with the idea that it has to be filled to the same level. Now if you look at burette, it can allow the flow of liquid, and we don't really care what is the initial level. We are just concerned with final volume minus initial volume. So we don't really care about same level. Same goes for gas syringe, same goes for measuring cylinder. But when we look at a pipette, it always has a specific mark on it, and there are no other marks on it. So we need to fill a pipette always to the same level, so it has to be option D for doctor. Aqueous sodium thiosulfate reacts with acid to make a precipitate of sulfur. A student investigates the effect of temperature on the rate of reaction. The student places a piece of paper with a cross on it below the reaction mixture as shown in the diagram, measures the time taken for the cross to no longer be seen, repeats the reaction at different temperatures. Which apparatus is needed for this investigation? So we are just concerned with the idea that he's concerned with temperatures, so perhaps thermometer. We are obviously looking at a beaker over here. Since it's 50 centimeter cube and not exactly 50.0, it could be measuring cylinder, it could be a pipette, or it could be a burette. Anything would work over here. Let's look at it. So balance, there's nothing known to be involving solid masses. We are not measuring the mass of substances, so I don't think balance is needed over here. We are obviously measuring time as well, so stopwatch is needed. But I don't think balance is needed. Let's look at option B again. Why do we need a balance? And stopwatch and thermometer make sense, but let's look at option C. A gas syringe, we don't need a gas syringe, there is no gas collection over here. A measuring cylinder to transfer the acid, a stop clock to obviously measure the time, a thermometer to measure the reaction at various temperatures, so option D is the right answer. A paper chromatography experiment is carried out to find an RF, which is reference factor value, for Fe3+ ions. The result is shown. So you have various chromatogram. So you have one chromatogram and you have various possible results. To make the spot containing Fe3+ more visible, the paper is sprayed with aqueous sodium hydroxide, so the precipitate of Fe3+ hydroxide forms. Under the conditions of the experiment, the RF of Fe3+ is given by number 1, and the color of the precipitate is number 2. Which row correctly completes gaps 1 and 2? So obviously it is concerned with this is the solute front and this is the solvent front. So RF should be equal to X divided by Y, because X is the solute front. So it has to be either A for apple or perhaps B for ball. Now when we spray sodium hydroxide over here, the Fe3 hydroxide is actually brown in color. So it is going to be red-brown in color, so A for apple is the right answer. The diagram shows two experiments. In experiment 1, when aluminium was added a few drops of sodium hydroxide, there is a white precipitate formed, an excess of sodium hydroxide. So since it's aluminium, I think the PPT should dissolve, because the precipitates of aluminium dissolve in excess sodium hydroxide. In the second experiment, copper is here. They're adding few drops of sodium hydroxide. Obviously it's a blue precipitate, and then blue precipitate does not dissolve, remain insoluble in sodium hydroxide. So the precipitates of aluminium dissolve and the precipitates of copper do not dissolve. So in experiment 1, the precipitate, the tick means they remain, so they don't remain, they dissolve. So the aluminium precipitates dissolve, but the precipitates of copper remain, so it should be C for cat, because copper hydroxide is not soluble. Which method of separation require a change of state from liquid to gas? Paper chromatography? No, sorry, it's not a separation technique, it's an identification technique. Crystallization, it involves evaporation, if you remember, making a saturated solution. Distillation obviously again it requires heating and then making vapors and then collecting the vapor while distilling them, while cooling them, while converting them back into liquid state. Filtration does not require a change of state. So when they talk about from liquid to gas, so do we involve heating? In crystallization we involve heating, in distillation we involve heating, but the other two don't require any such thing. So it has to be 2 and 3. We do heat over here, we do boil over here. Hydrogen sulfide and hydrogen chloride are both gases at temperatures above minus 50 degrees Celsius. Which gas will diffuse most rapidly at the temperature given? So we are just concerned with their molecular mass and we are also concerned with the temperature. So when we talk about the temperature, minus 40 is lower. And when we are concerned with the molecular masses, so H2S and HCl. HCl is 36.5 units of molecular mass, and when we look at H2S, it is going to be 34 units of molecular mass. So obviously HCl travels slower, H2S travels faster, because H2S has a smaller molecular mass. So when we look at the temperatures, it's going to be hydrogen sulfide because it's traveling more rapidly at minus 20, because minus 20 degree is higher than minus 40 degrees Celsius. So hydrogen sulfide travels faster at minus 20. I like this question a lot. Like, this question really got me thinking. The diagram shows the relative mass and the relative charge of two particles, the white circle and the black circle, present in atoms and ions. Which of these particles are present in a hydrogen atom and in a hydrogen ion? So when we look at this black dot, you can see it has a charge of minus 1. So which particle is this? It is an electron because it has a charge of minus 1. And when we look at this particle, the one that I'm highlighting with the green right now, the white dot, it has a charge of 0. And apparently it is heavier than the black dot. So which particle has a charge of 0? It has to be the neutron. So the white particle is the neutron, and the dark colored particle is the electron. I've written the spelling of neutron wrong. I know that I've misspelled it, but that's okay. So let's look at it. Which of these particles are present? H has no neutron because it is a simple atom. Hydrogen does not have a neutron in it, and it has one electron, so it has an electron. So it should not have the white dot over here. So since H is just a simple atom, it doesn't have a neutron, but there are isotopes of hydrogen out there which are known as deuterium, which have one proton and one neutron, so it could be a possibility. H plus, when we talk about it, it has no electron over here, so definitely it has no electron. It should not have the black circle. So it says option A says both white circle and black circle. Option A again for hydrogen ion says it says both neutron and electron. Option B says both neutron and electron, and for hydrogen ion it says neutron but no electron. So this makes sense. It has no electron, that makes sense. And option B also makes sense because they're saying that it has white circle, which is a neutron, and electron. But remember, generally when they're not talking about hydrogen deuterium, they generally mean without neutron. So just let's just keep looking at options. Option C says black circle, which means electrons but no neutron. Okay, this makes sense because hydrogen doesn't have neutron in most cases. 99% of the time it does not have a neutron. Option C continues to say neither electron nor neutron. Yeah, that makes sense. So hydrogen ion has no neutron or electron, and hydrogen atom has a electron but no neutron. So C for cat is the right answer. Which ion has the most shells that contain electrons? So for aluminium, it has an atomic number of 13. Generally, it has a configuration of 2, 8 because it has lost 3 electrons plus 3 charge. Beryllium has an atomic number of, if I'm not wrong, it has an atomic number of 4, and it's going to be like 2 since it's lost 2 electrons, so it's going to be just 2. Nitrogen has an atomic number of 7. With 3 extra electrons, it's going to become 2,8. Sulfur has an atomic number of 16. Its configuration is going to be 2,8,8 because it has 2 extra electrons. So sulfur has most number of electronic shells. Which substance conducts electricity both when liquid and when molten? That has to be a metal, because only metals conduct electricity in the solid state, or graphite also does that. An alloy, it conducts. Hydrocarbon, no sorry, they are covalent. Metal oxide, no sorry, they are ionic, they don't conduct in the solid state. Salt, again ionic, don't conduct in the solid state. So alloys are mixture of metals, they're going to conduct in the solid state. When they react together, which pair of elements form an ionic compound? Carbon and hydrogen are both non-metals, they're not going to make ionic, they're going to make covalent. Hydrogen and chlorine both are non-metals, so again covalent. Lithium is a metal, oxygen is a non-metal, so that is ionic. Sulfur is a non-metal, oxygen is a non-metal, again covalent. So C for cat is the right answer. How many shared pair of electrons are in one carbon dioxide molecule? So they are saying shared electrons, not pairs. Sorry, perhaps I read the word pairs. They're just concerned with electrons. Remember, you have one carbon and perhaps 2 oxygen atoms like this. This is your carbon, these are your oxygen atoms. They are making double covalent bond with each side. So it is 4 electrons involved here plus 4 electrons involved here, which means 8 electrons, or you can say 4 pairs. So they are concerned with the shared electrons, not the pairs, so 8 electrons are involved. Element X has a lattice of positive ions and a sea of electron. Which property will X have? It conducts electricity by the movement of ions and electrons. No, sorry. Metals don't involve the movement of ions. It has a high melting point. Yeah, that is true, because metals have high melting point. It is decomposed by an electrical current. No, sorry. Only ionic substances decompose by the electric current, which is known as electrolysis. It is not malleable. Sorry, they are malleable. So it's going to be having higher melting boiling point. Which row shows the correct state symbols for the reaction between calcium carbonate and dilute hydrochloric acid? If you remember, I have represented the equation. It looks something like this. This calcium carbonate is solid because it's insoluble. Hydrochloric acid is obviously aqueous because it's an acid. They produce water, which is a liquid. They produce carbon dioxide gas, and they produce calcium chloride, which is a soluble salt, again aqueous. So calcium carbonate is solid, hydrochloric acid is aqueous, calcium chloride is aqueous, water is liquid, and carbon dioxide is gas. So the answer has to be D for doctor. The expression shown for the value of AR for fluorine is incomplete. Average mass of, so they're concerned with the AR, atomic mass. This is known as the relative atomic mass. So average mass of one atom, because it's atomic mass, and it is compared to 1/12 of a carbon 12 atom. So we are concerned with 1/12, and atomic mass is atom's mass, not molecule. A mixture of 5 centimeter cube of methane and 100 centimeter cube of oxygen air is exploded. So air, sorry, not oxygen. Assume air is 80% nitrogen by volume and 20% oxygen by volume. The resulting mixture is cooled. All the volumes are measured at room temperature and pressure. So obviously, if you're concerned with 5 cm cube of methane, if 1 reacts with 2, then it means 5 should be reacting with 10 centimeter cube oxygen. And you can continue to extend it by saying if 1 methane produces 1 carbon dioxide, then 5 centimeter cube of methane would produce 5 centimeter cube carbon dioxide. Why are we not concerned with water? Because water becomes liquid at the room temperature that they are talking about. So out of the 100 centimeter cube air, you have 20 centimeter cube oxygen gas, because it's 20% of air. And out of the 20% of the oxygen that is available, 10 centimeter cube is reacting, and 10 centimeter cube oxygen is remaining because it is left unreacted. So what is the composition of the resulting gas? You will have 5 centimeter cube of carbon dioxide gas, so that is true. You will have 10 centimeter cube of remaining oxygen, that is true. All the nitrogen would be unreacted because nitrogen does not participate in the reaction. There won't be any steam because that is talking about room temperature, so there is no room temperature steam. It would have condensed into liquid. So B for Barrows is the answer because steam is gone as liquid, it's become liquid. Which arrangement is used to electroplate copper onto a steel key? If you have a key that looks like this, the key becomes the cathode, the piece of copper becomes the anode, and your solution has to be copper sulfate or any salt of copper. So electrolyte has to contain copper over here, so A or B. Anode has to be a pure piece of copper so that the copper ions can move towards the cathode from here, and the cathode has to be the steel key, so A for apple is the answer. The chloride of metal X is dissolved in water. A concentrated solution of this chloride is electrolyzed using inert electrodes, so concentrated solution. X is above sodium in the reactivity series, so X is very highly reactive element, very reactive. In addition to chlorine, which gas is liberated at which electrode? So obviously X has positive charge on it and it should go to the cathode. H plus ions also have positive charge on them, they should also go to the cathode. But since X is higher and H is lower, the H will produce hydrogen gas. So you will receive hydrogen gas on the cathode. So you're going to get hydrogen gas on the cathode, and while chlorine is going to go towards the anode. Which change in conditions for the reaction between zinc and dilute hydrochloric acid increases the rate of reaction by lowering activation energy? That is pretty simple. Lowering activation energy is always a catalyst. You don't even have to look at the other options. Many reactions can be classified as redox reactions. Which equations show redox reactions? Magnesium plus HCl. So you can see that magnesium had a 0 oxidation number in the beginning and then it became +2. So that is a kind of oxidation for magnesium. That is redox obviously. Iron, you can see that since it has FeCl2, iron had a charge of +2 in the beginning. But when it becomes FeCl3, it gets a charge of +3. So that is again oxidation for iron because it's changing from +2 towards +3. You can see sodium has a charge of 0 in the beginning and then it becomes +1. So sodium also becoming +1. And you look at bromine was 0 in the beginning because it was pure bromine, and then when it's in compound it becomes -1. So I believe all these reactions are involving redox one way or the other. Which row correctly shows whether the hydrogen ion concentration and the pH of ethanoic acid are higher or lower than those of hydrochloric acid of the same concentration? So HCl is a stronger acid that dissociates completely. Ethanoic acid is a weaker acid that does not dissociate completely. So hydrogen ion concentration of the ethanoic acid is going to be lower and the pH is going to be higher. For ethanoic acid, the pH is in the range of 4. For HCl, the pH lies in the range of 2. So you know which option to choose. In the next video, we are going to be doing the rest of the MCQs. Stay tuned, guys. Thanks.